This is John Black, Super Chemist, here to show you how to make some calcium hydroxide. Here's the equation. I'm going to use some calcium chloride and some sodium hydroxide. You can see I need twice as much sodium hydroxide than I do calcium hydroxide, calcium chloride. So I'll have to keep that in mind. Uh, it will make calcium hydroxide and some table salt. So damp bread has about 60 to 100% calcium chloride, 5% of two other salts, sodium and potassium. It's kind of a screwed up MSDS. It's stupid, but that's what I got. So I'm going to use 200 grams of damp red, and I'm assuming because I've already made calcium carbonate that it's a crappy percentage. So we're going to go by 60%, which would be 120 grams of the 200 would be calcium chloride. According to our stoichiometry, we're going to need twice as much sodium hydroxide. Now, if you got 111 grams is for a mole of this, and we're saying there's 120 grams in there, that's a mole and a 10% of a mole. So for the first mole, we're going to double this on here and make 80 grams. And then we used 100 grams to put in that extra 10% and to make it, we want a high pH, okay? That should give us 74 grams of, well, actually 10% more, 84 grams of calcium hydroxide. Now, this is a weird fact, but calcium hydroxide is actually less soluble in hot water. Okay, I know most stuff is more soluble when it gets hotter, you know, most salts, but not calcium hydroxide. It's the opposite. And the higher the pH, if you have other hydroxide anions in solution, that makes the calcium hydroxide even less soluble. So you want a high pH and you want it hot. Okay, and there's another reason why you want it hot. Okay, I boiled my water because carbon dioxide is not soluble in boiling water. Okay, and that is what is screwing up making hydroxides. Is carbon dioxide changes it into a carbonate so fast it's unreal. And I'm talking about like minutes. You'll have impurities. And I basically just did this video because I've tried to make hydroxide several times, and it just keeps turns into a carbonate. You can't have any carbon dioxide around when you're making a hydroxide or storing a hydroxide. You can see I have 200 grams of damp red there, 500 milliliters of water, and a thermometer. And I'm going to dump that in and dissolve it all. Thermometer is about 19 degrees. Why is it bubbling? Now it's at 40 degrees. Now I boiled that and I could not get it to all dissolve. So, and I couldn't get it out with a paper filter. So I used a frit filter and it did a good job getting it out. I'm doing it a second time here. But I cleaned out the frit thing in between there. And I cleaned it out with some hydrochloric acid and it was bubbling there too. So I don't know what that was. It was in there. Maybe some carbonate was in there. That was insoluble. So there I got it out. And it's crystal clear. It was crystal clear the first time I did it through the frit, but I'm doing it a second time. Now I'm going to boil this up and make sure it's really, really nice and hot. Everything hot, including the frit filter funnel. I'm going to have everything hot. Alright, I'm going to put this sodium hydroxide, like 95 grams, into this water, maybe about 200 milliliters. That should heat it up. My apparatus You see down at the bottom I have a round bottom flask, and it goes up with a Vigorex column. And on top I'll put a filter. Now I boiled the water that had the damper in it. I boiled all the carbon dioxide out. I don't know how good it'll be. I heated everything up. Okay, I'm going to add the sodium hydroxide to the damper. And I'm going to put it in the filter. Stir it up a bit. Now, this is the part because it's all wet. I don't know if it's going to work. I mean, because it's so hot, it might boil it off at a low pressure. Vacuum on it. Alright, let's see what we got here. Oh, there you go. There's a yield. That's like 105 grams. But I mean, there's probably 10-15 grams of water on there. Let's put it in some hydrochloric acid and see what happens. There's like zero fizzing. None. Wow, I did it. Alright, just to compare a couple things here. A couple carbonates and hydrogen carbonates. First, just a little bit of what we made already, the calcium hydroxide. You see how it fizzes now? Now it's calcium carbonate. Here's some potassium carbonate. Some sodium bicarbonate. See how it does it? It's a big difference. Alright, now I want you to keep in mind that, you know, I only washed it once, you know what I mean? I got the boiling hot water, I added in the sodium hydroxide, I got my precip, and I put it through the funnel. You should wash that more than just once. You should put some more hot water, boiling hot water, through your hydroxide, you know what I mean, while you're filtering it or whatever, to wash off some of that table salt that's on there. I didn't do it because I just wanted to see if it was even possible to make a hydroxide. Like, how fast does that CO2 come in and screw it all up, you know what I mean? So I did it once just to see, you know, make sure that it can be done. But keep that in mind, and always keep it boiling to make sure that the CO2 is kept out of your solution. You know what I mean? Plus, the calcium hydroxide is less soluble, so you can filter it out. Remember, you have to store this in a bottle. I mean, you've seen when I compared the carbonates, it only took a day or two for that calcium hydroxide to turn into calcium carbonate. And I didn't even throw it into water and take it out and throw it into water and take it out. I just set it in the glass jar and, you know, put it on a radiator. That was it. You have to boil the water to get the CO2 to stay out. And that means heat up your whole, I heated up my whole apparatus in the oven to make sure I didn't touch, you know, just start pouring boiling hot water through room temperature glass, you know what I mean? You don't want to do that. Always remember, keep the high pH. Throw in extra sodium hydroxide. Can't hurt. Now we started out with calcium chloride at 60%. That's 120 grams. That's like maybe 10% over a mole. So we should have gotten 10% over a mole for this because the stoichiometry was 1 for 1. But we ended up getting 105 grams minus 30 in water. That's 75 grams. We actually got we actually got almost pretty much exactly 1 mole. So we lost 10% of a mole there. So if we had 1 mole here, it was a 1-to-1 ratio for the carbonate, and a mole of that is 100 grams, but we only got 77, so we lost 23 grams there too. Anyways, always remember, science is great.